Hey JavaScript ninjas! Ever wondered how websites stay responsive while fetching data or performing complex operations? It's all about asynchronous programming. In just 7 minutes, we're diving deep into the core of modern JavaScript concurrency, promises and the game-changing async/await syntax. Get ready to write cleaner, more efficient, and non-blocking code that will elevate your applications. JavaScript is single-threaded, meaning it can only do one thing at a time. If we perform a long network request synchronously, our entire UI would freeze. That's where asynchronous operations come in. Historically, we used callbacks, which often led to callback hell. Promises were introduced as a cleaner solution, an object representing the eventual completion or failure of an async operation. Think of it as a placeholder for a value that isn't available yet. Async/await is syntactic sugar built on promises, making asynchronous code look and behave more like synchronous code, greatly improving readability and maintainability. Let's look at the core syntax. A promise is created with new promise, taking a resolver function with resolve and reject arguments. You consume a promise using .then, for success, .catch, for errors, and .finally, for cleanup. For async/await, you declare an async function, and inside it, use the await keyword before any promise returning expression. This pauses execution until the promise settles, returning its fulfilled value or throwing an error. Let's simulate fetching user data. We'll create a function that returns a promise, simulating a network delay with set timeout. If the user ID is valid, we resolve with user data, otherwise, we reject with an error. We then chain .then, calls to process the data and .catch, to handle any errors. Notice how .then passes the resolved value to the next handler, allowing for clear, sequential data processing without nested callbacks. Now, let's refactor our getUserData using async/await and add some complexity. We'll create an async function displayUsers that fetches multiple users concurrently using promise.all. Promise.all takes an array of promises and waits for all of them to resolve or any one to reject. Inside displayUsers, we use a try, catch block, just like synchronous code, for robust error handling. This makes our async code incredibly readable and maintainable, especially when dealing with complex flows. Watch out for these pitfalls. First, forgetting await in an async function. This will return a promise object, not its resolved value. Second, neglecting error handling, always include .catch, or try, catch to prevent unhandled promise rejections. Third, over-awaiting. If multiple promises don't depend on each other, use promise.all, to run them concurrently instead of blocking with sequential awaits. Lastly, don't fall back into callback hell by mixing old callback patterns with promises unnecessarily. You've just completed a hard-level sprint through promises and async/await. You now understand the core concepts, syntax, and how to apply them for cleaner, more efficient asynchronous code. Remember, practice is key. Try refactoring your own callback-heavy code, explore promise.race, and dive into real-world API integrations. The world of non-blocking JavaScript is now yours to conquer. Happy coding!